In this video on measurements, we are going to look at the total surface area of prisms and pyramids. Now the overview is quite simple. We're just going to look at the formulas and then just to look at a few examples on how to apply our formulas. The first shape that we're going to look at is the rectangular prism. Now when we're calculating the total surface area, we must remember to calculate all the four sides and then also the top and the bottom rectangle. So with the rectangular prism, we basically just have our six rectangles, and if we look at the net from the top view, that's quite clear to see. So when you're calculating total surface area, you can decide how you want to think about it, whether you want to draw out the net for yourself and put in the measurements and then just calculate the separate rectangles, triangles or circles, whatever you're working with. Or you can just look at it, think about it as in a 3D perspective, and remember that you have to calculate all the sides, including the top and the bottom. So our formula for the total surface area, that is now also if we are going to name our sides as length and breadth, and then our height is h. Then we see for the first part 2 length times breadth, that represents our base, because we have the area of a rectangle is length times breadth, and then we multiply it by 2 to accommodate for the bottom and the top. And then same here, breadth times height, this is going to be then the side. And there's two identical rectangles, the left hand and right hand side. And then lastly, the length times height is the front area and the back area, which is also identical, so we just multiply it by 2. Okay, next up we have the triangular prism. If we look at all the views, we can see that we have 3 rectangles as the sides, and then we have for the top and the bottom areas we have 2 triangles. So looking at its net as well, it will be clear to see that we have in total 3 rectangles and 2 triangles. And once again, you can decide whether you want to use the net or if you want to use the 3D object and work out all the sides. But the total surface area in this case will then be 2 times by half base times height. That represents the 2 triangles, and then we add AH, BH, plus BH plus CH. These represents the H normally represents, or the big H normally represents the height of the prism. And if we name our sides A, B and C, we can see our 3 rectangles. This is just length times breadth, length times breadth, and so on. And then half base times height. Now with these it is advisable not to just memorize the formulas off by heart and then try to substitute. These ones are slightly more complicated than the volumes formulas. You have to use your own discrimination as to thinking about it for yourself and knowing where these variables fit in or come from. Okay, next up we have a rectangular pyramid. So looking at the shape from all the sides, we can see there are 4 triangles on the slant heights, and that's the view from the top. And then if we look at it from the bottom, we can see that it is a rectangle as a base, hence a rectangular pyramid. And our total surface area is just the area of the base plus the area of the triangular faces. And in most textbooks just leave it as that, where that is basically your formula for it. We can write it as length times breadth, where the length times breadth just represents our base, and then the 2 triangles. Now it also depends if the base is a square, you can actually work out 1 triangle and times it by 4. If it's just a normal rectangle with different lengths and breadths, you're going to have to calculate the 1 triangle here and multiply it by 2, and then this triangle and multiply it by 2. But each sum has its own scenario. Okay, and then finally the triangular pyramid, looking at that or rotating that, we can see the sides. Once again, we have 3 triangles, and then that's the top view. And then when we look at the bottom view, we can see that the base is also a triangle. So in this case, we have a total of 4 triangles that we are going to calculate the areas of. And this total surface area is simply just area of base plus the area of the triangular faces. So you're basically going to look at the measurements that are given and use that to find the areas of the triangles and add them up together. Okay, so that was our formulas. Now let's look at applying them. Alright, so for example 1, here we have a rectangular pyramid, and in calculating the rectangular pyramid, what I need first is the slant height. What is given is the height of the pyramid, and also we can see that this is a square as our base. But obviously when we want to calculate the area of a triangle, we need the perpendicular height of that triangle, and in this case it's this height over here. And in order to calculate that height, we can see that we can form a right angle triangle right here, and that goes right in to the center of this line, and this obviously is the midpoint of the square, which makes this distance here half of the distance of our side, which makes that a 7 units. Okay, and then it's easy to use Pythagoras to calculate this height over here. So I'm going to say h squared, and since the height is, or the slant height, this is the hypotenuse of our right angle triangle, we add the other two, so that's 23 squared plus 7 squared. Then we take the square root, so 23 squared plus 7 squared, and we can calculate that. So that gives us 17 square root of 2, which we're not going to simplify further or round off or anything. Then calculating the total surface area, we have our 4 identical triangles. So that means we have 4 times by area of a triangle, half base times perpendicular height. So half times by our base is 14. And our perpendicular height, which we calculate, is 17 square root of 2. And then we add the area of the base of the pyramid, which is just a square, so that's 14 times 14, or length times breadth. And then we type that into the calculator. Okay, so that gives us 869,17. And our units, they haven't given us units, so we're just going to say units squared, and it's units squared since it's just a surface area. Okay, for example 2, calculate the total surface area in meters squared. Now, we can see that they're asking for it in meters squared, but they're giving us our units in centimeters. So we have one of 2 options. We can convert them now, the units, or we can first find the total surface area and then convert centimeters squared to meters squared. Although personally I just think it's easier to take centimeters to meters, so I'm going to convert them now, and I know that there's 100 centimeters in 1 meter, meaning I'm going to divide by 100. So this is 0.73 meters, this is 0.35 meters, and 0.42 meters. And then obviously we are shown or given that this side equals to this side, so this will also be 0.42 meters. Okay, now calculating the total surface area, we've got, if we look at this shape, we've got 3 rectangles here, and we have 2 triangles. Now, let's start with the triangles. We need the perpendicular height for a triangle, so let's construct this line in here. And to find that perpendicular height, we once again just going to use Pythagoras. So I'm just going to name that h, and h squared. In this case, h is our shorter side, so we take the long side minus the other shorter side. So h squared is equal to 0,42 squared minus the shorter side. Now this shorter side, we can see this whole long side here is 35. So half of that is 0.35 divided by 2, and that gives us 7/40, or 0,175. So 0,175. All right, so 0,175 over here squared. So h is the square root of 0,42 squared minus 0,175 squared, and that gives us 0.42 squared minus 0.175 squared, and that is equal to 0,38. If we should round off, let me just see that I've done everything here. Yeah, 0,38. 0,38. Okay, now we have all our information that we need. So I'm going to say that the total surface area is 2 of those triangles. So, and our triangle is half times base times perpendicular height. So half times this base, 0,35, times by the perpendicular height, 0,38, and then we add. Okay, so now we add the we've got 3 rectangles, although 2 of them are identical, because we have these sides that are the same, making the front rectangle the same as the back rectangle. So I'm just going to say 2 times by, and this is the length times breadth, so that's 0,73 times by 0,42, and then finally also adding the base, this rectangle over here, that's 0,73 times by 0,35. 0,73 times by 0,35. Okay, so then I can add all of those up. Total surface area is equal to, I have 2 times by 0,5 times 0,35. Okay, so this then gives me 1,0017. It's 1,0017. Now, since they haven't specified rounding off to, or how many decimal places they want, I'm going to leave it like that. So this is then in meters squared. Although if you are writing a test and they say round off to 2 decimal places, unless otherwise stated, if this was a test and that was one of the instructions, we would have rounded this off to basically 1 or 1,00. Okay, then for example 3, a rectangular prism with length equal to 20 meters and breadth equal to 30 meters and total surface area of 42,000 meters squared is given below. Calculate the height. Okay, now in this case I'm going to start off by writing out my formula, total surface area. equal to, so we have length times breadth, 2 length times breadth, plus length times 2 length times height, plus 2 breadth times height. Okay, and then we can substitute everything that we know. We know what the total surface area is, we know length and breadth, but we don't know height. So substituting in, we have 42,000 equal to 2 times by the length is 20 and the breadth is 30, plus 2, length is 20 and height is unknown, plus 2, breadth is 30, height is unknown. Okay, now we simplify everything and then we solve for h. So I've got 42,000 equals to, so this is 2 times 3 is 6, and that's 600 times 2 is 1,200, plus 40h plus 60h. And now just solving a linear equation, taking your variables to one side and your constants to the other side. So 42,000 minus 1,200 equals to, if I add these up, I get 100h. And then subtracting those two, we have 42,000 minus 1,200. That's 40800. 40,800 equals to 100 times h. Divide both sides by 100 so that these will cancel, and height is equal to 408 meters. Right, final example. A pyramid on a square base has a total surface area of 448 units squared and a slant height of 24 units. Calculate the length of the side of the base. Okay, let's just draw out what they've given us here. We have this right square base here. Just going to do this here. And it's a pyramid. So that point goes to the 4 corners there. Okay. And what they give us is the total surface area, and then the slant height. That means this height going down there is 24 units. Calculate the length of a side of the base. Now we need to remember that this is a square base, so if we can just assign a variable there, we've got x. So length times breadth would be x times x, and x is the value that we are looking for. So first of all, let's also write out the formula that we would use to calculate the total surface area in terms of x. So total surface area will be equal to, now we have 4 identical triangles, so we're going to say 4 times by my area of a triangle, half, times base, in our case now x, times by the perpendicular height, which is 24, plus, now the base of the rectangular pyramid is then going to be x times x, or x squared. Okay, now simplifying, let's simplify this and substitute also in our total surface area. Then our only unknown here will be x. So we have 448 equals to, so this is then 2, 4 times a half is 2, and then 2 times 24 is 48, so 48x plus x squared. And now we can see we have 3 terms here, and we have an x squared, which means this then becomes a trinomial. And a trinomial equation, we take everything to the one side, so 0 is equal to x squared plus 48x minus 448. Now factorizing a trinomial, we start off by taking the factors of 448, and we can start off, and we need to get factors that will add up to 48. So we can start off with 1. This can take a while though. 448 divided by 1. Okay, we know that is what that is. That's just 1 and 448. 2, let's see what 2 gives us, divided by 2. So that's 2 to 4, and that is not going to give us, it's not going to give us 48. Then divided by 448 divided by 3, That's not a number that can go in. 448 divided by 4 is 112. Not going to give us 48. 5 can't go in. 448 divided by 6 can't go in. 448 divided by 7 is 64. Now 64 and 7, getting closer, but it's not going to give us 48 either. And then 448 divided by 8, that's 56. Okay, now if I take 56 and I subtract 8, that actually gives me 48. So factorizing that will be, it's positive, so it's plus 56 minus 8. And that's then x minus 8 and x plus 56. And then this will mean that either x minus 8 is equal to 0 or x plus 56 is equal to 0. And solving for that, x is equal to 8 or x is equal to negative 56. And since a distance can't be negative, this is not applicable, so NA. And this then becomes our answer for the length of the base there, x.